Hey everybody, we are back on, let me see if I can get this to move, because these bubbles are really cool. There we go. We are back on recorded lectures, whether we like it or not, that's what it is. We're going to we're going to get in one more unit, okay, before our next test. And our test is going to be kind of treated as our final, but it's only going to be a unit test. Over this unit 3, and we're going to talk all about electrons. For today's lecture, it's going to be really beneficial if you have a periodic table open and visible. So you can either grab a printed out paper periodic table if you have one, or you can go to ptable.com right there. Oh, let's see. And you can kind of split screen it so you can see both the video and your periodic table. This might end up being a 2-video lesson. I'm going to kind of keep an eye on my time so I don't get cut off in the middle of something and then have to pick it back up later. So just kind of a heads up and a warning for you there. All right. But here we go with electrons. So the electrons in an atom are what does the bonding. Okay, so like the protons and neutrons and things inside the nucleus that we've learned about so far are basically the identity of the atom, and they have their own thing about nuclear chemistry. But for the most part, chemistry is involving electrons. Okay, so we need to understand what these electrons are doing, how they're located, what's happening for the electrons during a chemical reaction. Okay, so we have two types of compounds. We have covalent compounds. We have ionic compounds. For covalent compounds, we share electrons. Okay, the prefix co means together, and valent, we'll talk about valence electrons here in a sec, but those are the outermost electrons, and so these atoms are going to share their outermost electrons, or their valence electrons. Covalent compounds happen between metals and nonmetals, nonmetals and nonmetals. Okay, so on your periodic table, you can see the different categories of elements when two nonmetals, or maybe more than two nonmetals, come together in a chemical compound. That is considered to be a covalent compound. Okay, and this image up here in the top right kind of depicts that. Carbon and hydrogen are both nonmetals. Okay, and carbon has 4 valence electrons, that's represented by the blue. Hydrogen has 1 valence electron, represented by the red, and they are going to share them together. This molecule would be CH4 because we have 1 carbon and 4 hydrogens. Okay, and it is a covalent compound because they are sharing their electrons. Ionic compounds, however, involve the transfer of electrons. Okay, so sharing happens up here with covalent. Ionic involves the transfer of electrons. So sodium having 1 valence electron is going to give that valence electron to chlorine so that chlorine can fill this open spot right there. Okay, and what that does is gives sodium and chlorine a charge, okay, positive and negative, and now that positive negative attraction, we've talked about this before, opposites attract, and so now that positive negative attraction causes these things to stick together. Okay, and that would be an ionic bond as opposed to a covalent bond where electrons are shared. Okay, ionic compounds happen between metals and nonmetals. Okay, so again, if you look at your periodic table, you have the metals over on the left-hand side, you have the nonmetals on the right. Sodium being a metal, chlorine is a nonmetal. This is table salt, NaCl, sodium chloride, and it is an ionic compound. Okay? Let's talk just about ions for a sec. Okay, so we mentioned earlier that ions have a charge, and that charge, becoming a positive or a negative, that charge is because we gain or lose electrons. Okay? We do not gain or lose protons. If we do that, we change the identity of the atom. Remember from our last unit when we talk about number of protons identifies the atom? Okay, so number of protons always stays the same. We're talking now about electrons. And if we gain electrons or lose electrons, that's going to have an effect on the charge of that atom or molecule. Okay? Cations are positive. Okay? When we talk about ions, we have either positive or negative ions. Cations are positive. Because they are positive, we can think about they have more positive particles than they do negative particles, which gives them a positive charge. And if that's the case, then they have to lose an electron. Okay, so cations lose electrons. They give electrons away. That would be like sodium on the previous slide, the one that gave an electron away, and it becomes a positively charged ion. Anions are the opposite. They're going to take the electrons, and so they're going to gain more negative particles. Okay, so they're gaining an electron, and therefore it imparts a negative charge on that particle, on the ion or compound. Okay? You need to be able to remember these cations and anions, and there's a really simple way to do so. So cations are positive, and in the word cation, there's a plus sign right there. The T, the lowercase t, gives you a plus sign to tell you that this is a positively charged ion. And in the word anion, there's a negative sign. Your little crossbar on the A is a negative sign to tell you that anions are negative. Okay? Simple, easy peasy. Make sure you remember what cations and anions are. Okay? We're going to talk now about Lewis dot structures or Lewis dot diagrams. And this is a way to visualize or to diagram how things bond, how chemical bonds happen in terms of electrons. Okay, so here's where we need our split screen looking at different elements on the periodic table. This is a definition for valence electrons. Valence electrons are in the outermost orbitals, or the outside electrons. Okay, and as we go across the periodic table from left to right, we gain valence electrons. Okay, this is hydrogen here with 1. That's supposed to be an H. Okay, helium only has 2 because it's small. Then we come back here to lithium with 1 again. Okay, and then as we work our way over, then we get to our 3, 4, 5, 6, 7, and 8. Okay, as you go down the periodic table, those numbers are going to stay the same. All right, we'll talk about this a little bit later. But the valence electrons, as you go down and you stay within a single column, those valence electrons remain the same. Okay, so everything here in this first group here all have 1 valence electron. Everything over here, carbon and below, all have 4 valence electrons. Oxygen all has 6. Everything below oxygen has 6 valence electrons. Okay, that's going to be important for us as we move forward in these Lewis dot structures, is being able to identify where our atoms are, where the elements are on the periodic table, and identifying how many valence electrons we have in each one. Okay, so we're going to dive right in here, and I'm going to give you some atoms that I want you to draw the Lewis dot diagrams for. The first one is oxygen, and you're going to have to copy off of me for this because you don't have any practice or any sort of idea of what we're doing. Okay, so for Lewis dot structures, you are going to draw or write the element symbol. So for oxygen, it's just O. And you're going to represent each electron with a dot. Okay? The Lewis dot diagrams are going to document, let me go back here, document how many valence electrons we have for each atom or element. Okay, so for oxygen, if we look back at our periodic table and we know, okay, so 1, 2, 3, 4, 5, 6, 7, 8, oxygen has 6. All right, so we need to represent 6 electrons on this Lewis dot structure. Okay, and we just do that with little dots. Okay, so we're going to put 1, and we're going to start at the top and go clockwise. Okay, so there's 1, 2, 3, 4, and then we start to double up. 5, 6. And once we get to 6, then we stop because oxygen only has 6 valence electrons. Okay? Let's do another one. Let's do magnesium. If you look at magnesium on the periodic table in your rows, you can identify that magnesium has 2 valence electrons. Okay, so we start at the top. There's 1. There's 2. That was easy. Okay, chlorine. Go identify how many valence electrons chlorine has. Should be 7. 1. Oh, that kind of looks like 2. So we start at the top. Let's go 1, 2, 3, 4, and then we double up. 5, 6, 7. If you look on that slide, the previous slide, the maximum that you can have on a certain element is 8. Okay, so we have 4 sides here, and we can do a maximum of 2 per side, which gives us 8 total valence electrons. Okay? Next one is Na+. So this is the sodium ion, Na+. This means that we have a change in the number of electrons. Okay? It has a positive charge, so if we think about, and I'll just write out here sodium, if we have a sodium atom, sodium is number 11, so it has 11 protons and 11 electrons. It's in the first column, so it has 1 valence electron. But if it has a positive charge that we see here, that means that it has lost one of its electrons. Okay? So if we think about this, it only has 1 valence electron to start with. It loses that electron. So the way that we write this as a dot structure, it's not going to have any dots around it. It lost. So this is what sodium would normally look like. Just Na with a single dot. It lost this electron. And so now we put it in brackets and put a plus sign over it. Okay? These brackets tell us that I didn't just leave this blank on purpose. I know that it lost the electron. Now it's an ion and it has a positive charge. Okay? So if you ever have an ion, whether it's positive or negative, and you're doing a Lewis dot structure, make sure you put it in brackets. So here's the next one. S-2. So we have sulfur. And if we look and find sulfur, we know that normally it has 6 valence electrons, but it has a charge of -2, so that means it gains 2 negative particles or 2 electrons, and so now we have 8. And so we're going to start 1, 2, 3, 4, 5, 6, 7, 8. This is an ion, and so we put it in brackets and put the charge on the outside. Okay, I'm almost out of time on this video. we're going to stop. This is the end of the first video. I'll record a second one.